Our lesson for 6.4, we're going to split up into a couple of parts. So the first part of 6.4, so we're going to go over the exponent rules again, but this time we're going to have rational exponents, which is just a very fancy way of saying fractions. So the same exponent rules that we learned in the previous lesson are going to come into play here. The only added bonus challenge that we're going to have is doing the arithmetic with the fractions. I'm going to show you how to do them without a calculator, but remember you're going to have a calculator, for most of my summatives where you can just type in the fraction work and then hit math enter if you want to bring it back to a fraction. So the first property, remember, said if we're trying to multiply two bases together and they have exponents, you can keep the base and then add the exponents together. So for this problem, we're going to keep the base of 3, and then if we add 1/2 plus 3/2, remember when you add fractions, they have to have common denominators, which this set does. So you keep the denominator of 2 and you add the numerators. So 4 over 2, which reduces to 2. So my new exponent is going to be a 2. You could have just typed 1/2 plus 3/2, math enter. Well, you didn't have to press math enter on that one. Okay, the next property says that when you have a power raised to another power, you can simplify that by multiplying those powers together. So in this question, we're going to keep the base of 4, but we're going to have to multiply the power of 3/2 times 2. Remember, 2 is 2 over 1. So when you're multiplying fractions together, you can either multiply across the numerators and denominators and then reduce, or you could reduce and cross-reduce before you multiply. It's up to you. Since I don't have a calculator to use today, I'm going to reduce first. This is all one big numerator, so the 2's are actually going to cancel out each other. It's called cross-canceling, and we end up with a new exponent of 3. Now notice I'm not continually simplifying these. They do have numeric bases, but we're trying to illustrate the exponent property, so it wouldn't really help me. I need to further simplify, but I have to realize that there is some equivalency in math. Right, this next example is if you have two bases being multiplied together inside of a set of parentheses, this is the only time you're allowed to distribute an exponent, so it can go to each of the bases. So in this case, this property would say 9 to the 1/2 power, times 4 to the 1/2 power. Now we're going to learn in the follow-up part of this lesson that 1/2 power is the same thing as the square root. So square rooting 9 is the same thing as a 3. Square rooting 4 is the same thing as a 2. So we could take this answer all the way down to an equivalent answer of 6. When you're taking your SAT test or your ACT test, sometimes you've only partially reduced or you have an equivalent answer to what they're offering you for choices, and you have to see all that equivalence. Remember, the negative exponent rule says that whatever that base is that happens to have a negative exponent is on the wrong side of the fraction bar. So in this particular case, the a value, the base of a, would move to the denominator, and then the exponent is now positive. So here, there is a denominator of over 1, so the 25 has a negative exponent with it. So we could move the fraction 25 to the negative 1/2. Oh, it's not negative anymore, is it? So since we moved the exponent, or the base, I should say, the exponent is now positive 1/2. There is still a 1 in the numerator because you have to have something. If you wanted to take this further, this is really the square root of 25, which is 5. So this reduces all the way down to 1/5. The other property we need to look at is if you have the same base and you're trying to divide the bases, but they have exponents, you could simplify that by keeping your base and then subtracting the exponents. So in this case, we're going to keep our base of 6, but we're going to have to subtract our exponents. And just like when you're adding fractions, when you subtract fractions, you need common denominators. We already have common denominators. So this becomes a 4 over 2, which is a 2. So 6 squared is a good answer. 36 is equivalent. And then this quotient property says that you could distribute the exponent to both of the bases in the numerator and in the denominator. So in our example here, this would become 8 to the 1/3 power over 27 to the 1/3 power. And remember, 1/3, just like 1/2 meant square root, 1/3 is going to mean cube root, which we're going to actually learn in the follow-up to this lesson. So the cube root of 8 is 2. We have a chart for this. And the cube root of 27 is 3. So to illustrate the properties, I don't mind which answer you give me. We just have to be able to tell that there are equivalent things going on. All right, the first few examples here are going to be numeric bases, and then we're going to switch to algebraic bases. So here, I have the same base trying to multiply them together, so I'm going to keep the base of 5. But the very first property we learned says that if you want to add these properties, these exponents together, you're going to get a singular base of 5. So let's see, 1/2, I'll write up here, 1/2 plus 1/4. Well, I have to have common denominators to add fractions together, and the least common denominator for this addition problem would be a 4. So if I just multiplied this fraction by 2 over 2, that would become 2 over 4 plus 1 over 4, which is 3 over 4. Again, math around your calculator will suffice for now. These are not the same base, so there's no way I'm going to be able to combine this 8 and this 5, but using the property that says I could distribute the 2, the second power, to both of the bases, and then I'm going to use a follow-up property that says I'm supposed to multiply those together. So this first term becomes 8 to the, it's going to be 1/2 times 2, which is going to cross cancel to just a 1, times, and then here it's 1/3 times 2, nothing cross cancel, so it just ends up being 2/3. So as far as what's your best answer, technically this is it. 8 times 5 to the 2/3 power. 5 to the 2/3 is, I don't even know, something really weird. It's like 2 point something. So it's not a nice answer. All right. This is the same set of properties. We're going to distribute the negative 1/4 power. We're going to multiply the exponents together because of the other property. And then if we happen to have some negatives, which I think we're going to in this one, we're going to have to move some terms around. So this is going to become 2 to the 4 times negative 1/4 is going to be negative 1. And then same thing here, 3 to the negative 1 when I multiply those. But this would not be a good enough answer because anything with a negative exponent means that that base is on the wrong side of the fraction bar. So the 2 to the first and the 3 to the first are both going to move. I have nothing left in my numerator, so I'm going to use 1 as a placeholder. And then you can say 2 to the first times 3 to the first, or you could even take this all the way to say 1 over 6. Great answer. There is an exponent on number 4. They have the same base, and this guy does have an exponent of 1. So using my properties of exponents, I'm supposed to subtract. So keeping your base of 7, if I do 1 minus 1/3, well, you can't subtract 1 minus 1/3 because they don't have the same denominator. So I would rewrite 1 as 3/3. So 3/3 minus 1/3 is going to be 2/3, and I think we're done. So some kids would argue, oh, I'm just going to type all those in my calculator and get weird decimal answers, and then if it was on the SAT test, I just match it up. But you know, we have to be able to use the properties and give the most simplified answer, because sometimes you'll see questions like this where they have algebraic bases and you can't type this in the calculator. Here, we're going to keep our base of x, but we do have to subtract our exponents. So 5/6 minus 2/3, they do not have common denominators, but a common denominator for this problem would be a 6. So what if I multiplied this fraction by 2 over 2? That would work, right? Because you'd have 5/6 minus 4 over 6, which is 1 over 6. So new answer, x to the 1/6 power. Make sure that your exponents are superscript and they are small, you know, in relative size to the base. Sometimes I get kids writing things like this, and then they want to know why I counted it wrong. And I'm like, because you didn't write x to the 1/6 power. You wrote something like totally different. That's not good. All right, same property here. We're going to keep our base of y, but we're going to have to subtract these exponents. So 1/4 minus 3/8. So a common denominator here would be an 8. So what if I hit this one by 2 over 2? That becomes 2/8 minus 3/8. Turns out that right now I have a negative 1/8 as an exponent, which means I'm not done. Because anything that currently has a negative exponent, that particular base or that term has to move to the other side of the fraction bar. So the y to the 1/8 is going to go to the denominator, and we're going to leave 1 up in the numerator. Now, when you move on in math, or if you are, you know, working with a different teacher than me, technically we can't, this is not like a acceptable way to write the answer. The denominator is not rationalized because this is the 8th root of y, and there's some weird rule out there in math that says you can't have a radical in the denominator. I've heard from teachers who are teaching college that they're actually kind of abolishing that rule. So we've taken, at Harlem, we've taken the approach of, you know, let's not worry about that. Rationalizing denominators in this case doesn't really make any sense. So it is possible that on an SAT test or an ACT test, this might not be an answer choice. So you're going to have to do a little bit of work to figure out which of the answers is equivalent to yours. So trust me when I tell you, I'm very happy that you don't have to rationalize those denominators. 7 is the same property, so keep your base of 10. 5/6 minus 4/6. I feel like we just did this problem 1/6. Well, we did that subtraction problem at least. All right, and that's not negative, so we're just going to leave it. Here, keep the base of x, but I'm going to have to add the exponents together. 1/4 plus 2/4, awesome, because those already have common denominators. So the answer comes out to 3/4 for my new exponent. Again, make sure your exponents are small and they're superscript. So I don't know if you're putting this together yet, but if you understand your exponent rules, this particular lesson should be very, very easy. The only added glitch is that you have to know how to work with fractions. It always kind of boggles my mind when kids feel like this is different, because it's not. All right, 2/3 times 4 is going to be my new exponent. So 2/3 times 4 doesn't look like anything cross cancels, but if I multiply across the numerator and denominator, I get a new exponent of 8/3. So x to the 8/3 power is the answer I'm looking for. There's no, this is just a singular property they want you to do in this question. So I don't have to combine any exponents because there's only the one term, but this particular term has a negative exponent, which means it needs to move. So x to the 7/2 is now in the denominator with a positive exponent, and then 1 is left in the numerator. Again, if someone's requiring you to rationalize the denominator, this would not be an okay answer. All right, number 11. I need to multiply these exponents together. So 3/5 times 1/6. This one I could cross cancel before I try to multiply it together. 3/6 is really 1/2. So 1/10 is the product of those exponents when you reduce it. So this becomes x to the 1/10 power. And then here I gotta subtract. So 5/3 minus 2/3 is 3/3, which is a really boring one. So the answer there is x. You can say x to the first, that's fine. That was kind of boring, sorry. All right, so I will warn you, the problems that I'm going to ask you to do for practice are a little more elaborate than that, where they might use like 3 or like all the properties all at the same time in one problem. So the frustrating part, just like with the other exponent rule problems, is you and your neighbor might have a different approach to the question, but you'll still end up with the same answer if you just continually use the properties. So there's not one right answer for like how to approach the problem. You just have to start using the properties one at a time, and hopefully you choose an efficient method.